Hello and welcome to this video. In this video, we will solve problem number 91 to 100 of geometric progression. So let's get started. And as always, do not look at the solution immediately. You should pause after seeing the problem. And then if you cannot solve it, only then look at the solution. So problem number 91 says that if the sum of the series r to the power n, sum of r to the power n where n starts with 0 and up to infinity, modulus of r is less than 1 is s, then find the sum of the series summation of r to the power 2n with n is equal to 0 up to infinity. So we write the sum as 1 plus r square. The summation evaluates to that up to infinity. Now clearly this sum is 1 by 1 minus r, which is equal to s. So you can write that r is equal to 1 by s minus 1. Let me think, it might be incorrect. So s will come here and r will go there. Yeah, it should be 1 minus 1 by s. And r to the power 2n will become 1 plus r square plus r to the power 4 and so on is equal to 1 by 1 minus r square. So this will be 1 by 1 minus, here in the brackets it would be 1 minus 1 by s whole square, which you can evaluate. Problem number 92 says that if for a GP, mth term is 1 by n square and nth term is 1 by m square, then find the term t of m plus n by 2th term. So we have Tm is equal to ar to the power m minus 1, which is 1 by n square. Obviously here first term is a and common ratio is r. Nth term is equal to ar to the power n minus 1 is equal to 1 by m square. We divide these, we get r to the power m minus n is equal to n square by m square, which is r is equal to n square by m square whole to the power 1 minus 1 by m minus n. Now we have found r, so we can find a by substituting it either in Tm or Tn. Once we have a and r, the desired m plus n by 2th term can be found, which I have left for you to compute. If a, b, c be three successive terms of a GP with common ratio r, sorry, there is spelling mistake, and a less than 0 satisfying the condition c greater than 4b minus 3a, then prove that r greater than 3 or r less than 1. We let c to be ar square and b is equal to ar. Given that c is greater than 4b minus 3a, that is ar square greater than 4ar minus 3a. We cancel out a, we get r square greater than 4r minus 3. So we take 4r minus 3 to the left hand side and then we factorize. We get the factors as r minus 1 and r minus 3 is greater than 0. Clearly this is true only if r greater than 3 or r less than 1. Problem number 94 says that if 1 minus k multiplied with 1 plus 2x plus 4x cube plus 4x square, it should not be 3, 4x square plus 8x cube plus 18x to the power 4, it should be 16, plus 32x to the power 5 is equal to 1 minus k to the power 6, where k not equal to 1, then find k by x. So it should be 16 again here. 1 plus 2x plus 4x to the power 3 plus 8x cube plus 16x to the power 4 plus 32x to the power 5 is equal to 1 minus k to the power 6 by 1 minus k. So this is a geometric progression with the common ratio 2x. So this becomes 1 minus 2x whole to the power 6 divided by 1 minus 2x. And this is 1 minus k to the power 6 divided by 1 minus k. Clearly k is equal to 2x, so k by x is equal to 2. Problem number 95 says that a square plus b square c square multiplied with b square plus c square plus d square less than equal to ab plus bc plus cd whole square, where a, b, c, d are non-zero real numbers, then show that they are in GP. So we bring the right hand side to left hand side and we rewrite the given inequality. We get b to the power 4 minus 2b a square ac plus a square c square plus c to the power 4 minus 2c square bd plus b square d square plus a square d square minus abcd plus b square c square less than 0. This becomes b square minus ac whole square plus c square minus ad whole square plus ad minus bc whole square less than 0. Now this is possible only if this is 0 and this is 0 as well as this is 0, which is b square is equal to ac, c square is equal to bd, ac is equal to bd. This implies that b by a is equal to c by b is equal to d by c. That is a, b, c, d are in GP. Problem number 96. It says that if a1, a2 up to an are n non-zero numbers such that a1 square plus a2 square plus up to an minus 1 square plus a2 square plus a3 square plus up to an square less than equal to a1 a2 plus a2 a3 plus up to an minus 1 an whole square, then show that a1 a2 up to an are in GP. So this is similar to the previous problem, just that the number of terms have increased. So we consider only a1 a2 a3 and we get this value, which is less than equal to 0. That is a1 a3 minus a2 square is less than 0. So this cannot be negative, this can be only 0. So if this is 0, then a1, a2, a3 are in GP. And similarly, you can prove for rest of the terms. Problem number 97 says that alpha beta be the roots of x square minus 3x plus a is equal to 0, and gamma delta be the roots of x square minus 12x plus b is equal to 0, and the numbers alpha beta gamma delta form an increasing GP, then find the values of a and b. Since alpha, beta, gamma, delta form an increasing GP, we let them to be k, kr square, k, kr square, kr cube, where r is greater than 1. So sum of the roots is, for the first equation, it would be alpha plus beta, that is k into 1 plus r, which is equal to 3. It has come from the formula of quadratic equations. So if you're not studied quadratic equations, then you can skip this problem. And sum of roots of the second equation is equal to gamma plus delta, that is kr square multiplied with 1 plus r is equal to 12. We substitute s over here, so we get k 3r square is equal to 12, which gives us r is equal to 2. If r is 2, then k is 1. Now we have r and k both. So we say that product of roots is, for the first equation, is k square r, that is alpha beta, which is equal to a. And product of roots for the second equation is k square r to the power 5, which is 32, is equal to b. So from here we know that a is equal to 2, b is equal to 32. Problem number 98 says that there are 4n plus 1 terms in a certain sequence, of which the first 2n plus 1 terms are in AP of common difference 2, and the last 2n plus 1 terms are in GP of common ratio 1 by 2. If the middle terms of both the AP and GP are same, then find the midterm of the sequence. We are given that common difference is 2 and common ratio is 1 by 2. So middle term of the sequence would be 4n plus 1 by 2. That is 2n plus 1th term, because number of terms is odd. So this term is the last term of AP, first term of the GP, and middle of the whole sequence. So this term is nothing but a plus 2nd, because tnth term is a plus n minus 1 into d. Here a is a and n would be 2n plus 1. So 2n plus 1 minus 1 is 2n into d. D is 2, so it becomes a plus 4n. Now we let capital Tn plus 1 and small tn plus 1 are midterms of AP and GP. Again, there is a typing mistake here. So for the AP, we have Tn plus capital Tn plus 1 is equal to a plus and d is equal to a plus 2n. And for the GP, it would be, the first term is capital T 2n plus 1th term. Don't forget that. So this multiplied with r to the power n, which is equal to a plus 4n into 1 by 2 to the power n. Now it is given that the middle term of AP is equal to middle term of GP. So a plus 2n is equal to this much. Solving this, we get a is equal to 4n minus n into 2 to the power n plus 1 divided by 2n minus 1. Now you can calculate the midterm of sequence. Problem number 99 says that if fx is equal to 2x plus 1 and three unequal numbers f of x, f of 2x, f of 4x are in GP, then find the number of values for x. So here f of 2x is 4x plus 1 whole square is equal to f of x into f of 4x. F of 4x would be 8x plus 1. So this gives us 2x is equal to 0, therefore x is equal to 0. So what we had to find was x. So we have found x. Oh, where is problem 100? Oh, problem is here. It should not be solution, it should be 100. Actually, I made this slide just now, and I did not revise it, so there are lots of problems. Three distinct real numbers a, b, c are in GP such that a plus b plus c is equal to xb. Then show that x less than minus 1 and x greater than 3. We let r to be the common ratio, then we have a plus ar square, that is a plus b plus c is equal to x into b, that is ar. So the quadratic equation which we get is r square plus r into 1 minus x plus 1 is equal to 0. Now since common ratio is real, the discriminant of the quadratic equation should be greater than 0. That is 1 minus x whole square minus 4 greater than 0. This is only possible if roots, that is minus 1 will be one root of this equation and 3 would be another root. So it is possible only if x is less than minus 1 or x is greater than 3. Thus we have found the range of x for which we have the condition satisfied. So with this we come to the end of problem number 100. In my next slide I will make 10 more videos, 10 more problems, and I'll explain those to you. If you have found this video informative and useful, please like the video and subscribe to the channel because it motivates me to make more videos. Thanks a lot for watching.